Today we're going to be looking at fish kill day 5. This is a continuation of molarity and looking at concentration. We're going to be looking at dilutions. So thinking about the fish kill as pollutants, or like aluminum as one of them, travels down the river, will it dilute, become more concentrated? What does that mean as it passes through more river water? So we're going to play the FET here first to start off. Then there are 3 questions to answer. What do you notice about the relationship between concentration and the amount of solvent? So we're going to look at a graph that you're going to make. Looking back at the map of day 1, if the fish kill was caused by a pollutant, where would it take place? So think back to day 1. What that map look like? It says total fish kill zone, partial, minimal kill zone. So look at close to the total kill zone. Where would that have to take place there? Where would the pollutant be? Why does the concentration decrease as distance from the polluting site increases? So as you get farther away from Anderson, why does the concentration decrease, do you think? So explanation there. The bottom down here, 1 is a math problem to solve. You are given moles, so you don't have to convert. Here you're given grams. You will have to convert grams to moles. Your answer will be in moles. And then the final answer. And then for 3, which one has a higher concentration? You will solve for the first one, and then you will solve for the second. These are different concentrations of calcium chloride. Then highlight or circle whichever one has the higher concentration. You can highlight either one of these or circle them, whichever one is the highest. When doing the FET, we have some water, so it wants us to first say water is at a half a liter, set the solution to cobalt nitrate solution. So up here on the right, it says solids. There's different solids to choose from, and then there's solution right here. So solution, it wants cobalt nitrate. There's a whole bunch of different options here, but we're going to go with cobalt nitrate. Add 2 squirts of cobalt nitrate to the water. Then move the tool to measure the concentration of the solute in the half liter of water and record the data in the table. So we're going to add 2 squirts. There are my 2 squirts. It's at half a liter. We are going to drag the concentration meter over here. So with 2 squirts, the half a liter, it says, is 0.091, is what it records at. So what we're going to do is you'll make a text box and put 0.091. That's what we're going to record right here. Then it says add or evaporate water 1/10 at a time and record the concentrations. If you add too much, it evaporates. So what we'll do is we can slowly add water. Every one of these lines is a tenth. So here's 5/10, 6, 7, 8, 9, and the full liter is 10. So if we add water, add it slowly. Whoop! See, I went too far there. So I can evaporate. As close to the line as possible. Okay, so now it's on my line. So 0.77. And this is increasing, so it'll be 6/10 is 0.077. So we'll add our text box. And we have the concentration there. And yours might be slightly different. On the recordings, it might be off by like 0.1 or exactly like this. So same thing, we'll add a little bit more water for our next concentration. So we want to go up to the next line. So 0.066. So make sure you record them correctly. There's there's a decimal here, 0.066. That's for 7/10. And that's molar, that's concentration. So think about what is happening to the concentration as we are adding more water to it. Is the concentration increasing or decreasing? Then we're going to draw. Use whatever color you would like to draw on our chart here. So half a liter is 0.091. So 0.91, since we went this way, we are at 6/10. So 6/10 is here. So there's 0.91. 0.077. and then 0.066. And you'll draw these the same for anything 1/10 and over. Let's see. Oop, I put my 9-1 in the wrong spot, so we'll erase those. Get our drawing one more time. And I have it on size 4 right now for thickness, so here we go. 5 is 0.091. So 5.091. And you'll do that the whole way till you get to the full liter, and then to the 1/10 of a liter. And the 1/10 of a liter, you can decrease or you can evaporate. So there's your 4/10, 3, 2, and you just have to move this as you go. There's the 1/10. And that's the closer you get to 0, you'll see the number increasing here. So you'll just continue to do that when you're making your graph here, and that'll help you answer the first question. What do you notice in the relationship? So once you have your graph, then you will, you can go back, you can pick a different stroke here, different color, and then you can kind of connect your dots. Better than that, but you can connect your dots like that on your graph to see if there's any kind of increasing trend, decreasing trend, what would the graph look like. And that is the fish kill day 5 for dilutions.